I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
Imagine sitting in the cockpit of a modern jet where every flick of your fingers on the controls is instantly translated into precise movements of the aircraft. This is the magic of the Digital Flight Control Computer, or DFCC, the digital brain behind fly-by-wire technology. Gone are the days of heavy hydraulic linkages and mechanical cables. Now, the aircraft listens to your commands through the language of electrons and code. Today, we are diving into how DFCCs keep planes steady, safe, and responsive, while also exploring the real risks and the exciting future of autonomous flight. At the heart of DFCC lies a complex network of flight control computers, sensors, and actuators. Think of the FCCs as the jet's brain cells. They take pilot inputs, autopilot instructions, and a flood of sensor data like airspeed, altitude, acceleration, and even the angle of attack, and instantly figure out how to move the elevators, ailerons, rudder, and flaps. The actuator control electronics then turn those calculations into precise mechanical movements. It's like conducting an orchestra where every note must hit perfectly in sync. The DFCC doesn't just react, it constantly thinks ahead. Pilot pulls the stick. The DFCC calculates hundreds of control surface adjustments in real time. Gust of wind hits. It compensates instantly, keeping the aircraft smooth and stable. Autopilot engaged. The DFCC decides exactly how to adjust each surface for the most efficient and safest flight. And it does all this millions of times per second, silently and flawlessly. DFCCs operate under different flight laws. Normal law is the fully automated, envelope protective mode. You can't stall, overspeed, or bang too sharply. It keeps the aircraft within safe limits. If some sensors fail, the system slips into alternate law, still controlling the plane but with slightly fewer protections. And in the worst case, direct law hands the controls straight back to the pilot, cutting out computerized intervention. This layered approach is like having multiple safety nets for every flight maneuver. Redundancy is everything here. Most modern jets have triple or quadruple FCCs, all calculating in parallel. The DFCC votes on which signal makes sense, ignoring faulty readings and keeping control smooth. Even actuators and sensors have backups. But, and this is a big but, redundancy isn't infallible. If the system misreads consistent but wrong sensor data, it can lead to serious consequences, something the aviation world has unfortunately learned the hard way. Take the May 8, 2024 RSAF F-16 crash. Two gyroscopes failed, giving similar readings, and the DFCC rejected the one accurate backup. The pilot had no choice but to eject. The plane went down because the system trusted the wrong sensors over the right one. This incident shows that even a high-tech, redundant DFCC can be vulnerable if it can't properly identify faulty inputs. It's a stark reminder that technology, no matter how advanced, must be designed carefully. So, what's next? Imagine DFCCs powered by AI, predicting turbulence before it hits, adjusting surfaces preemptively, optimizing fuel efficiency, and reducing pilot workload. AI could detect sensor anomalies instantly and isolate errors dynamically, preventing mistakes like those that caused the F-16 crash. The potential for smarter, safer skies is enormous. Eventually, DFCCs might allow fully autonomous flight, commercial jets, cargo planes, or even military aircraft navigating entirely on their own. With advanced sensor fusion, predictive algorithms, and high-speed computation, autonomous DFCCs could redefine aviation safety and efficiency. In short, DFCCs are the silent heroes of the skies, blending human input, digital intelligence, and mechanical precision. They make flight safer, smoother, and smarter, but real-world lessons remind us there's always room for improvement. The future. Smarter, AI-driven, and maybe even fully autonomous skies where DFCCs take aviation to levels we've only dreamed of.